Okay, so here f of x is equal to x cubed minus 2 all over x plus 2. So let's start by finding the asymptote. So we'll start with the vertical asymptote. Here we see that x equals negative 2 makes the denominator 0, but we'd have to also see if it makes the numerator 0, because if it does, then x plus 2 would cancel. But we have negative 2 cubed minus 2, which is negative 8 minus 2, and that's not equal to 0. Okay, so x equals negative 2 is a vertical asymptote. Then we have to look for the end behavior asymptote. So since the degree of the numerator is larger than the degree of the denominator, we know that the end behavior asymptote is not horizontal, so we can use polynomial division to find it. But let's use synthetic division. So we have negative 2. 1, 0 is the coefficient of x squared, 0 is the coefficient of x. Then we have minus 2. So we bring down the 1, multiply, add, multiply, add, multiply, add. So this is our remainder. And so what this tells us is that f of x is equal to x squared minus 2x plus 4 plus the remainder divided by x plus 2. So when we're looking for the end behavior asymptote, this term here is insignificant, so that means y equals x squared minus 2x plus 4 is the end behavior asymptote. Okay, now let's find all intercepts. We'll start with the x-intercept. Remember that the only way for a fraction to be 0 is if the numerator is 0. So we set x cubed minus 2 equal to 0. That tells us that x cubed equals 2. So x is the cube root of 2. And that's approximately 1.26. Okay, to find the y-intercept, we set x equal to 0. So we have 0 minus 2, which is negative 2, over 0 plus 2, which is 2. So y equals negative 1 is the y-intercept. All right, now let's give the domain. The domain is everything except negative 2, which makes the denominator 0. So negative infinity, comma, negative 2, union negative 2, comma, infinity. Okay, next we want to plot the extrema, intercepts, and asymptotes, and the calculator's okay on here. So let's start by finding the extrema. So if we go to y equals, so we enter the function, we get x cubed minus 2 divided by x plus 2, and we graph it. Alright, so here, this right here, so that's going down to our vertical asymptote at x equals negative 2, and that's following our end behavior up, 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 up. But we see there's no graph for this portion, and that's a red flag because the domain is supposed to include x going from negative infinity to negative 2. So we need to find out a window that's going to allow us to see this part of the graph. So let's press trace, and then we're going to put x on the other side of negative 2 and see what the y values are. So we see as x gets close to negative 2 from the right hand side, the y values are going down to negative infinity. Okay, and then once we get on the other side of 2, we see that the y values are here at 91. So for my window, so I can see the rest of the graph, I'm going to make it, say, go to 100. Okay, so now I can see this extrema right here. We have a relative minimum, so I'm going to find that. Second, trace down to minimum. So for the left bound, I'll go on the other side of that on the other side of that minimum. So it's there. And on the other side, it's there. With our guess. So we see we have a minimum at the point where x is about negative 3.1 and y is about 28.9. Okay, so here I'm going to plot the extrema, intercepts, and asymptotes. So we have a vertical asymptote at -2, so I'm going to go ahead and plot that. We have the extrema at -3.1, 28.9. So 28.9, that's going to be somewhere up here. Okay, so there's my minimum. So now I'll plot the intercepts. We have an x-intercept of about 1.26. So that's around there. We have a y-intercept of -1. So that's going to be around there. And so let's see, we have the extrema, we have the intercepts. I only have one of the asymptotes, so now I'm going to plot the other asymptote. So on the calculator, we know the other asymptote is y equals x squared minus 2x plus 4. So since this is a calculator active problem, I'm going to just go ahead and use the calculator to find that. So get rid of this for a second, and then just plot x squared, y equals x squared minus 2x plus 4. And I'll do zoom 6. And we can find the vertex there by finding the minimum. So left bound, we press enter. Right bound, guess. So it's at the point 1, 3. So here's 1, 3. And I'm going to do a little precision of this end behavior asymptote. So that's a vertex at 1, 3. I know the y-intercept is going to be 4. So it's around right there. And then I'm going to also find out where it crosses the vertical asymptote. So it's going to cross the vertical asymptote where x is 2. So we have -2 squared minus 2 times -2 plus 4. So here we have 4 plus 4 plus 4, or 12. So I know that my end behavior asymptote crosses the vertical asymptote at the point -2, 12. Okay, so so I know that this is my relative minimum right there. I'm also going to find out where my end behavior asymptote lies relative to that, and so I find out the y value on the end behavior asymptote when x is -3. So we have, say, do it up here, -3 squared minus 2 times -3 plus 4. So that's 9 plus 6 plus 4. So 15 plus 4 is going to be 19. So for my end behavior asymptote, when x is -3, the y value is 19. So it's right around there. All right, so we plot this. Okay, so these, now I have plotted the extrema, which actually there's only one, there's an extremum, a relative minimum, the intercepts, and the asymptotes. Now for the last part, I would like to sketch the graph of f of x. So here we go back to the calculator and get rid of this graph, and I want to see that graph. So press graph. And I want to make my window big again so I can see the other part of it. Okay, so this part here, that's going down to our vertical asymptote at -2. So here we know this is going down here, and then hitting this X-intercept, and following the end behavior asymptote on that side. And then here we have our relative minimum, and this is following up the vertical asymptote on that side, on the left side of -2. So here it's going to be going up, 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 up there. And this side is following the end behavior asymptote toward -infinity. So that's going to be following that. Okay, so here, this is the graph of the function.